All right, thanks for that report, Ben Kirui. And of course, we're looking forward to the ceremony tomorrow. But to our conversation tonight. Last week, we highlighted the worrying high levels of fluoride in borehole water in Nairobi. Well, the impact of this has been even more concerning, and that is the increasing cases of dental fluorosis, which causes porous and stained teeth in children aged 8 and below. So we told you about the problem last week, but tonight we are shifting focus to the solution. Interestingly, Naivasha and other parts of Nakuru were considered endemic when it came to dental fluorosis. But some interventions to deal with the high levels of fluoride in groundwater is slowly changing that narrative. Joining me in studio is engineer Nahashon Wahome, Managing Director of Naivasha Water and Sanitation Company, and Sarah Mutua, a civil engineer specializing in water resources engineering at the Technical University of Kenya's Department of Water and Environmental Engineering. Thank you both for joining me this evening. Susan, let me begin with you, because this was a question that kept coming up, especially after our special report last week. Why do we see such high levels of fluoride in our groundwater, and specifically to the areas of Nairobi and the Rift Valley region?
Groundwater, or other fluoride sources, we have two sources of fluoride in water, natural sources and anthropogenic sources. Man-made sources. When we are talking about man-made sources, most of them are from processing industries, especially those industries that use fluoride as an input in the processes. The wastewater or the solid waste from such sources, from the processes, if discarded wrongly, they can cause contamination of groundwaters and surface waters with fluoride. When we look at natural sources of fluoride, fluoride is a naturally occurring chemical in rocks, in soils, on the ground. When the fluoride occurs in soluble form, and it comes in contact with groundwater, then it can become soluble and it is going to flow into water. In places where we have high fluoride levels, it is areas where we have active volcanic activities. In Kenya's Rift Valley, and especially Nakuru area, Naivasha area, that is an area where we believe we still have active volcanicity. For the Nairobi aquifer system, which starts from Limuru area and flows towards the river, we have the fault line where we also have the recharge zone around the fault line. And because of that, we expect to have high fluoride levels in those two areas. Essentially, both the Rift Valley, Nakuru and Naivasha aquifer, Nairobi aquifer, their origin can be taken back from volcanicity, and because of that, we expect these high levels of fluoride.
Okay,
yes.
So is just groundwater the only source that we should be worried about when it comes to high fluoride, or surface water also an issue?
Mostly groundwater, because in groundwater we have high contact times of the water and the formations where the water occurs, which contain the fluoride, and because of that we have the high, high levels of fluoride. Yes.
Engineer Wahome, let me come to you, because people weren't really clear when it comes to water sources. So we have groundwater and we also have surface water. When you come to Naivasha, for instance, what is the main source for your area?
Thank you, Victoria. For Naivasha, we rely on groundwater, 100%. Okay. So us as Naivawashco, we supply water from boreholes. So currently we have about 17 production sites, and each and every production site has a number of boreholes that we produce water from.
So when it came to the levels of fluoride that you found in your water, what was the next step? What did you find was a big concern?
The first thing is that especially between 2010, 2020, we were suffering a lot from high levels of fluoride.
Yeah.
And we tried to, first of all, come up with different solutions. It has been quite a journey. So the first solution that we came up with was boncha. And boncha is basically superheated bones, and then they are crushed. And the challenge with boncha is it can only treat water in small scale.
Okay.
So what we'll do is we would put the treatment systems on a kiosk, water kiosk, or communal water points. And we still needed to get more or better treatment systems. So the first thing also, the other thing that we did was to try and find out whether we can be able to get better sources of water. Yeah. So we were able to collaborate together with Wheat and Saivides and also WRA, Water Resources Authority, and we did mapping of fluoride within Naivasha. So we were able to establish several aquifers where the fluoride levels were below 1.5, one near Daramia and another one in DTI. And we tried to drill more boreholes there. However, the water from those boreholes is still not sufficient because the demand for water is still growing. So now we got into another technology. There's a technology that we borrowed from Germany called HAP. HAP is it's pellets where they are manufactured, or they are synthetic boncha, and they are more effective and efficient than boncha. So what we did was we did a pilot to see whether we can be able to use HAP as a treatment agent. And HAP basically has, we can be able now to use HAP as in large scale, to treat water in large scale. And again, also, it is more efficient and cheaper as compared to boncha. Whereas HAP, we can be able to, the cost of treatment from HAP is like a fifth of what we can use in boncha. Okay. So basically, HAP was more cheaper, more efficient, and much better than boncha itself.
So what will it take to actually scale such interventions?
So the major thing is to continue with these studies. So what we've been able to do is we are able to now design a system that can be able to treat water in large scale. And the challenge has been now getting resources to now scale it up to other production sites. So currently we have that system in only one production site, but we are now looking for funds to be able to do other systems in other production sites.
Sarah, let me come to you because Engineer Wahome talked about the shortage of water. We sometimes forget that Kenya is a water-scarce country. What does that mean in terms of now supplying water to the population that is still growing? We've heard in Naivasha they rely primarily on groundwater as a source. But moving forward into the future, what does that mean in terms of water supply?
First of all, a water-scarce country, it means that the per capita consumption in a year is less than 1,000 cubic meters. That is, each person cannot get 1,000 meters cubed of water, fresh water, sustainable fresh water. To make matters worse, in Kenya, 2/3 of the country is arid and semi-arid. So what it means, even the distribution of this water, fresh water, which is already not enough, is variable throughout the country. What it means, therefore, especially in these arid and semi-arid areas, in urban areas where we have rapid urbanization, population growth, we may not have much choice but to go to the sources that are available, even those are high in fluorides, high in salts, high in electrical conductivity and what have you, and look for solutions so that we can be able to treat this water to drinking water standards.
So when you look at, and I'm sure you've done mapping and projections of how long
Yes.
our current supply will last, what does that look like?
Unfortunately, in our country, when it comes to groundwater resources, we can say it is work in progress. Because one of the challenges that we have had, especially when in meeting the SDG 6 about water and sanitation, is the lack of data. So we could say at the moment it is work in progress, and it is an opportunity for professionals in the country to be able to come up with databases and create databases for this information. But as it is, we probably are not in a position to state it as a country.
You know, we're facing more or less the crisis that you dealt with in Naivasha here in Nairobi, Engineer Wahome. When you look at our situation, because borehole water is essentially what is making up for the difference of what we're getting from the dams in Ndakaini and others that's around Nairobi. But what lessons can we learn from what Naivasha has managed to do to defluoridate or remove the fluoride from water?
The good thing about boreholes is it's quicker to develop boreholes.
Yeah.
And it's much more cheaper as compared to dams. So we still need borehole water, especially for areas where we are not able to get surface water. So one of the things I believe we can be able to do is to establish and know where we can be able to get good quality water. Then we need to concentrate developing boreholes in those areas. Mm-hmm. Then the other thing again is we have to take deliberate actions and invest in treatment of borehole water. Most of the efforts right now are going towards treating surface water. Everywhere we have dams or surface water abstraction, there is a treatment plant. Mm-hmm. I think also it's important for government to also ensure that they have treatment systems for fluoride in each and every borehole that they develop. And we have possible solutions. We have treatment technologies that are available, like Boncha amongst other things, and also HAP. And I think it is possible for government to invest in those. And with that, we can be able to deal with the menace of fluoride.
And when it comes to your perspective, Sarah, and I'll finish with you, what do you feel can be a solution in scaling some of these defluoridation interventions for a place like Nairobi?
In Nairobi, when you look at the situation we have in Nakuru, it is an area where we have some of the highest levels of fluoride, not only in Kenya, but in the world. Mm-hmm. The technology that is working in Nakuru, already they have characterized their groundwater in terms of how much fluoride there is. The first step for these other areas is also to first characterize their levels of fluoride, and in addition to HAP, in addition to Boncha, look at other alternative methods of removing defluoridation so that they can select the best method suitable for their areas. In Nairobi, the concentrations of fluoride may not be that high, although Boncha HAP technology can also be applicable in Nairobi. Again, we also look at, we should also look at social cultural acceptability of these methods. Again, in Naivasha, Nakuru, the initiative is already led by government institutions. When you come to Nairobi, most of the boreholes are individually owned. So such kind, yes, private owned. So such kind of large-scale applications of defluoridation may not be applicable, and we may have to look at smaller scale methods of defluoridation. Yes.
Okay, thank you. Thank you so much, Sarah and Engineer, for coming in. That's all the time we have, but hopefully this begins that conversation and looking a bit more critically when it comes to the high fluoride levels in our borehole water, yes, not just in Nairobi, but also in Nakuru as well. Let's take a short break. Sports news coming up next.